solve this problem, we start by analyzing the given condition. The limit as x approaches 0 of f of x plus x divided by 2x is equal to 3. Now multiply both sides of the equation by 2. That gives us the limit as x approaches 0 of f of x over 2x plus 1/2 equals 3. Next, subtract 1/2 from both sides. So we get the limit as x approaches 0 of f of x over 2 equals 5/2. Now multiply both sides by 2 again to isolate f of x over x. That means the limit as x approaches 0 of f of x over x equals 5. Now we use this result to evaluate the target limit. We are asked to find the limit as x approaches 0 of 2f of x plus 3x divided by f of x. To simplify, divide both the numerator and the denominator by x. This becomes the limit as x approaches 0 of 2 times f of x over x plus 3 divided by f of x over x. Since we know that f of x over x approaches 5 as x approaches 0, we substitute that value in. So we have 2 times 5 plus 3 over 5, which equals 13 over 5. Final answer, 13/5. This is a solid and general method, and it works well here. However, to prepare for slightly harder problems, it's a good idea to practice using the next approach. We are given that the limit as x approaches 0 of f of x plus x over 2x equals 3. Let's define a new function. Let q of x be equal to f of x plus x. Then the condition becomes the limit as x approaches 0 of q of x over 2x is equal to 3. Now, in order for this limit to exist, the numerator q of x must also approach 0. So q of x must include a factor of x. We can write q of x as x times h of x. Substitute that into the expression for f of x. We get f of x equals q of x minus x, which is x times h of x minus x, which simplifies to x times the quantity h of x minus 1. Now, plug that into the target expression. We want the limit as x approaches 0 of 2 f of x plus 3x divided by f of x. Substitute our expression for f of x. The numerator becomes 2 times x times the quantity h of x minus 1 plus 3x. The denominator becomes x times the quantity h of x minus 1. Factor x from both the top and the bottom. Now we have x times the quantity, 2 times h of x minus 1 plus 3, divided by x times the quantity h of x minus 1. Cancel the x terms. We're left with the limit as x approaches 0 of 2 times h of x minus 1 plus 3 divided by h of x minus 1. Now go back to our earlier expression. Since q of x equals x times h of x, the limit of q of x over 2x is the same as the limit of h of x over 2, which equals 3. Multiply both sides by 2, so h of x approaches 6 as x approaches 0. Substitute h of x equals 6 into the simplified expression. We get 2 times 6 minus 1 plus 3 divided by 6 minus 1. That's 2 times 5 plus 3 over 5, which equals 10 plus 3 over 5. And that gives 13 over 5. Final answer, 13/5. Now take a look at the next question. You'll see that this time, the first method won't work as easily. Let's solve it together using this second approach. We are given the following condition. The limit as x approaches 0 of the absolute value of f of x minus x divided by 2x is equal to k, a finite value. To evaluate the limit, we first need to understand the behavior of both the numerator and the denominator as x approaches 0. The denominator, which is 2x, clearly approaches 0. So in order for the entire fraction to have a finite limit, the numerator, absolute value of f of x minus x, must also approach 0. That tells us that f of x minus x must contain at least one factor of x. But there's more. Because the numerator includes an absolute value, the limit will only exist. If the left-hand and right-hand limits are the same, this symmetry across 0 can only happen if the inside of the absolute value becomes 0 at the same rate from both sides. So to ensure both 0 behavior and directional agreement, f of x minus x must contain at least one factor of x. And to fully cancel out the denominator 2x, it should actually contain x squared. That leads us to assume f of x minus x equals x squared times h of x, which implies f of x equals x plus x, squared times h of x, where h of x is some function that is continuous, or at least finite. As x approaches 0, we are now asked to evaluate the limit as x approaches 0 of 2 f of x plus x divided by x. Let's substitute our expression for f of x into the numerator. Recall that f of x is x plus x squared times h of x. So 2f of x is 2 times x plus x squared h of x, which gives 2x plus 2x squared h of x. Now add x to that expression. That gives 3x plus 2x squared h of x. So the full limit becomes the limit as x approaches 0 of 3x plus 2x squared h of x divided by x. Now divide both terms in the numerator by x. That gives 3 plus 2x h of x. As x approaches 0, 2x times h of x approaches 0 as well, since h of x stays finite. So we're left with 3 plus 0, which equals 3. Final answer, 3.